For generations, the American classroom operated on a straightforward mechanism: direct instruction. A teacher stood at the front and broadcast a single lesson at a uniform pace. It was a one-size-fits-all model built for a homogeneous audience. Today, that homogeneous audience no longer exists. Modern classrooms reflect a massive demographic shift, with non-European descent populations making up over a quarter of the student body. High variance is the modern reality. Add to this the reality of physical transiency. Roughly 40 million Americans move each year. A single classroom's population can almost entirely turn over between September and May, continually resetting the cultural and academic baseline. The legal framework has also evolved. Under the Individuals with Disabilities Education Improvement Act, the practice of limited mainstreaming has been replaced by full-time inclusion. Students with documented physical, emotional, and cognitive exceptionalities now learn alongside their general education peers. This creates a strict instructional paradox. Educators are legally and professionally required to deliver a unified curriculum to a highly fragmented cognitive and linguistic population. Diversity in education is a mechanical design challenge. Delivering standard results from varied starting points requires an engineering solution. That solution is differentiated instruction. It is the systematic process of customizing instructional delivery so every student can acquire and process the same core material. To execute this, a single learning objective is divided across 3 distinct vectors of modification: content, process, and product. These vectors are manipulated to align precisely with a student's current academic readiness, their personal interests, and their unique learning profile. Modifying instruction does not mean lowering expectations. The standards remain high. Differentiation simply builds alternate, accessible pathways to reach that high-level mastery. The classroom functions as a dynamic system. Instead of expecting the student to contort themselves to fit the curriculum, the teacher modifies the environment to fit the student. Before adjusting the instruction, an educator has to map the variables. Take language. Millions of students are English language learners. Schools deploy pull-out systems or sheltered classes to integrate them, requiring the teacher to constantly bridge linguistic gaps using visual displays and dual language texts. Cultural norms dictate communication. A student avoiding eye contact might be showing respect according to their cultural background, while another interrupting might be demonstrating active engagement. Misreading these nonverbal cues degrades classroom rapport. For students with special needs, the data source is codified in an Individualized Education Plan, or IEP. These documents dictate the precise developmental levels and the legally mandated instructional accommodations a teacher must provide. At the other end of the spectrum, gifted and talented students require their own variables mapped. Their instruction demands an increase in cognitive complexity, like developing their own hypotheses, rather than just a higher volume of standard busywork. Mapping these variables is a baseline operational task. An educator must aggressively identify the strengths, limitations, and specific needs of their room. Effective instruction relies entirely on the precise, objective mapping of these cultural and cognitive inputs. To map those inputs, schools use formal diagnostic tools. Response to Intervention, or RTI, is a tiered screening strategy that focuses on tracking student outcomes rather than documenting deficits. By screening students as early as kindergarten, RTI identifies those who are struggling and immediately applies targeted, research-based interventions within the general education setting before they fall behind. Beyond academic screening, teachers must measure how students actually process information. Dunn & Dunn's Learning Styles model provides a framework for evaluating individual learner preferences. This grid outlines the 4 parameters of learning styles: environmental factors like lighting and sound, emotional factors like persistence, sociological preferences regarding group size, and physical variables like sensory mode and time of day. Because many of these traits are not outwardly observable, bypassing teacher bias requires formal instrumentation. A structured learning styles record form accurately charts a student's modality and social preferences. The data extracted from RTI and learning inventories serve as the objective blueprints needed to begin mechanical classroom modification. The first vector of differentiation is content. This is exactly what the student needs to learn, and the specific materials deployed to grant them access to that information. For a student struggling to process complex text, standard delivery fails. The teacher modifies the content vector by deploying leveled readers, bilingual software, or recorded texts, ensuring the core concepts transmit successfully. This schematic is a classroom modification plan. It tracks adjustments across 3 categories: exam, assignment, and content. Under assignment modification, teachers might reduce task length or provide study aids. Content alternatives swap standard lectures for visual aids, video demonstrations, or hands-on discovery. By manipulating this first vector, the curriculum remains intellectually rigorous, but the access point becomes physically and linguistically viable for the student. The second vector is process. These are the specific sense-making activities a student engages in to master the content they've just accessed. To differentiate the process effectively, educators apply Howard Gardner's theory of multiple intelligences. This circular matrix maps 8 distinct intelligences, moving past just linguistic and logical mathematical abilities. Process differentiation maps teaching strategies directly to these nodes. A logical mathematical learner analyzes concepts using manipulatives. A naturalist internalizes data through outdoor observation, while a bodily kinesthetic learner requires movement-based role-play. Process differentiation also requires bypassing physical barriers. This is where assistive technology becomes crucial. Tools like closed-circuit monitors, braille readers, or voice-activated software are essential components of the inclusive process, allowing students to navigate complex tasks. Engineering the process vector means designing lessons that deliberately light up the diverse cognitive strengths operating in the room. The final vector is product. This is the culminating project, the specific mechanism a student uses to apply, extend, and prove what they have learned. Relying entirely on uniform written testing often fails to measure actual knowledge. For a student with fine motor difficulties or a language barrier, a standard essay test measures their limitation, not their mastery of the subject. Differentiating the product provides diverse output options. A spatial learner might demonstrate historical knowledge by building a precise diorama. An interpersonal learner could perform a simulated interview or a puppet show, while others compile multimedia presentations. To maintain standardized assessment across these wildly different formats, educators use strict rubrics. The criteria for success remains locked, even as the delivery method changes. Offering flexible products allows a student to lead with their innate strengths while still fulfilling the core curriculum requirements. Differentiating the product ensures that a student's communication or physical barrier is never mistaken for a lack of cognitive achievement. The complete system operates efficiently. Educators map the input variables using diagnostic engines like RTI, and then adjust the delivery matrix across content, process, and product. Effective instruction requires systematically designing units around all 8 intelligences, making them a consistent structural feature rather than a sporadic bonus activity. Within this framework, high teacher expectations function as a positive self-fulfilling prophecy. Students achieve because they are given realistic, accessible opportunities for success. Leaving these student background variables unaddressed creates a bottleneck in the system, potentially preventing a significant portion of the population from reaching the level of proficiency required for global citizenship. The modern teacher functions as an engineer of accessible pathways. The objective is a classroom where a single standardized curriculum goal results in diverse, deeply individualized, but equally valid evidence of mastery. When this architecture of differentiation is properly installed, the educational system successfully opens its doors to every student. By treating variance as a design parameter rather than an obstacle, the inclusive classroom becomes a functional model for a society where diverse profiles contribute to a unified standard.